Okay, so now instead of dealing with numbers, we're going to compose functions without substituting a value in for x and getting down to a simplified number. So for number 1, we have f of g of x. So our input, our innermost function is the entire function g of x. Well, g of x is equal to 2x minus 1. So we're going to use the substitution property. So it's very similar to when we did systems of equations by the substitution method. This is going to look very similar to that. Because what we're going to do is we're going to take whatever g of x is equal to, which is equal to 2x minus 1, and I'm going to replace g of x with 2x minus 1. But I'm not going to just put it in here. I'm going to substitute that into my outermost function, which is f of x. So not only is g of x going to be 2x minus 1, but I'm actually going to substitute that into our x in our f of x. And I know that sounds confusing. Just me saying it makes me laugh. But our innermost function is g of x. So I'm going to figure out what that equals. Well, that equals 2x minus 1. That's my innermost function. That's my input. So I'm going to take that 2x minus 1, and I'm going to substitute or replace anywhere I have an x in my outermost function, which is f of x, with this 2x minus 1. So f of x is x squared. So instead of saying x squared, I need to say 2x minus 1 squared. So here's my g of x. I substituted or replaced g of x with 2x minus 1. That 2x minus 1 is going to be put into my outer function, which is f of x. Another way you could have thought of this maybe is writing this out. Instead of f of g of x, it's f of 2x minus 1. So anywhere I have an x in f of x, I'm going to replace that x with this 2x minus 1. I realize it's a lot of arrows. So instead of x squared, we get 2x minus 1 squared. Now, be careful. A common mistake is people will square the first term, square the last term, and you get 4x squared plus 1, and you think you're done. You have to be careful. I would suggest that you just go ahead and write these out. So there is a shortcut. If you know the shortcut, fantastic. If you don't, then don't worry about it, because I don't want you to miss that middle term. So you'd be 2/3 right if you did your shortcut, but you would still be wrong. Anytime something is squared, we're saying it's that times itself. And if we just go through the process of distributing, 2x times 2x gives me a 4x squared. 2x times this negative 1 gives me a negative 2x. Now, negative 1 times 2x gives me another negative 2x. And then negative 1 times a negative 1 gives me a plus 1. So if you would have done it your shortcut way, you would have gotten the 4x squared right, and you would have gotten the plus 1 right. What you would have missed, though, is this middle term that would have been lost. So when I combine like terms in the middle, if I have a negative 2x, taking another negative 2x away, I would get a negative 4x. Those are the only like terms that I have, and so you see that you would have had those two terms right, but you would have missed this middle term. So what we're saying is that f of g of x, so f of g of x is equal to 4x squared minus 4x plus 1. So if I were to substitute my innermost function, g of x, into my variable for f of x, this is what I would get after I simplify. It is weird at first. Once you do it a few times, it's not too bad. There is another example, though, number 2 here, where what happens if you're substituting the same function into itself? That seems kind of strange. I also want to remind you about this notation. It's read the same way, reading from left to right. This is h of x. If you see an open circle, that is a composition of functions. If you see a dot, that is multiplication. So just be careful. So it's h of x. So now what I'm going to do is I'm going to replace this 4x minus 3 into both of these. I'm going to substitute 4x minus 3 into itself. So really what we're saying is instead of h of x, I'm really saying h of 4x minus 3, because that is what h of x is. Now, everywhere I have an x in h of x, I'm going to replace that x with 4x minus 3 again. So it's kind of a double substitution, or being substituted into itself. So instead of 4x times 3, this is going to be 4 x is being replaced with 4x minus 3, and then minus 3. So what we did is we took the first h of x, our innermost function, which is 4x minus 3, and we substituted that or replaced the x that was already there with h of x. So instead of 4x minus 3, it's now 4 times the h of x minus 3, or 4 times 4x minus 3 minus 3. You do want to use parentheses here. That way you can distribute properly and simplify or reduce properly. So when we see parentheses, we should think distributive property. 4 times 4x is 16x. 4 times the negative 3 is negative 12. And then this minus 3 is not being multiplied, so this minus 3 is attached at the end. I do have two like terms. I have a negative 12 and a negative 3. So finally I get 16x minus 15. So what we're saying is, in this format, we have h of x equals 16x minus 15. So composition of functions in this sense can be a little more challenging, but try to think of it as substitution. I find my innermost function, so whatever's on the innermost part of the parentheses, I'm going to take whatever that equals and I'm going to substitute that into what's on the outermost part of the parentheses. Where it can be challenging is that the innermost function here was h of x, so I'm going to take this 4x minus 3, but I'm substituting that back into itself, which just seems kind of strange, which is why I wanted to give you an example. So I'm taking that 4x minus 3, and everywhere I have an x in that same function, I'm going to replace that with itself, 4x minus 3. And so once you reduce and simplify as much as you can, you stop here because we don't have any numbers to plug in to try to find out what that actually equals.